Hi guys, welcome to today's tutorial. Today we were looking at modular arithmetic. Okay, now when we talk about modular arithmetic simply is similar to binary numbers or number-based systems. Okay, centric, but now modular arithmetic focuses more on secular events that happens at specific dates. Okay, now for example, looking at market days, let's say we have market days of every 5 days. Okay, market days of every 5 days. Now we can calculate each market day by every 5 days. So if our first market day is on Monday, now the next market day will be by Friday, which is 5 days from Monday. Okay, so modular arithmetic is just similar to number-based systems, all right, where your mode which you work with has same digits with the mode with base. Let's say we are working with mode 3, it has same digits with base 3. So having that understanding of number-based system, it will be easier to work on modular arithmetic. Okay, all right. Another thing you need to understand in modular arithmetic is that modular arithmetic focuses also more on your remainder, just like a number-based system. What you have left after dividing your numbers is what you write down. Okay, so same way with modular arithmetic, it focuses on what is remaining after your divisions. So for you a better understanding of modular arithmetic, you need to understand your multiplication table and your division table. Okay, now looking at our example here, it says use the number cycle below to simplify the following. Now this, from this number cycle, we can see we have 0, 1, 2, 3. Now just these digits, and from here we can deduce that this is in mode 4, because our digits from mode 4 are 0, 1, 2, and 3. Remember that your digits cannot be greater than your number, the base which you're working with. Same thing with modular arithmetic. The digits of a mode cannot be greater than the mode which you're working on. So here, now looking at our A, question 1A, we have 1 plus 3, which gives us 4. Okay, so if we divide 4 by 4, so if we have 4 divided by 4, we have 1. Any remainder 0. Now, since it's remaining 0, this will give us 0 mode 4. Like I said earlier, we are interested in what's our remainder. So this will give us 0 mode 4. So for 1b, we have it as 3 plus 8, which gives us 11. And 11 divided by 4 would give us 4 into 11 will give us 2, which is 8, remainder 3. Okay, so this will give us 3 mode 4. As long as our remainder is still within the digits of the mode, we'll write it down. Okay, now C gives us 5 plus 12, which is 17. So this will be 17 divided by 4 would give us 4. 4 times 4, 16. All right, 16 plus 1, 17. So 4 remainder 1. So this would be 1 mode 4. And the D, which is 9 plus 21, which gives us 30, will be 30 over 4 to give us 4 times 7, 20, 4 times 5, 20, 4 times 6, 24, 4 times 7, 28. So this gives us 7, remainder 2. Alright? So this gives us 2 mode 4. Now, this is one way of solving it. But now let's look at choosing a number cycle as they said. So if we have 4, okay, 3 plus 1 is 4. So starting from 0, we'll count 4. This becomes 1, 2, 3, 4, which brings us back to 0. So 3 plus 1 will give us 0 mod 4, because if we start from 0 as our starting point and count 4 steps, 1, 2, this way, we are counting 4 steps clockwise, 1, 2, 3, 4, our value will end at 0, which gives us 0 mod 4. Now, looking at 3 plus 8, which is 11, so still starting from 0, we count 11. So this becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the position 11 stops at number 3. That's why we have it as 3 mod 4. Alright? Now, looking at 5 plus 12, which gives us 17. Still starting from 0 point, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So our 17 stops at 1. So we have it as 1 mod 4. Alright? Now looking at the next one, which is 9 plus 21, which gives us 30. Okay? So now from here, we have it as counting 30 from starting from 0 point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 30 stops at 2, which gives us 2 mod 4. So now with this, we've used a number cycle to calculate our modes. Alright, another method of solving this is simply if we have 1 plus 3, okay, now this gives us 4, we can expand this in our multiplication to be 4 times 4 to give us 4, 1 times 4, alright, will give us 4, plus 0 still gives us 4. So this is our remainder, which gives us 0 mod 4. Alright, now another for D, which is 3 plus 8 equals 11. Alright, so this gives us 4, this will be 3, 2 times 4, 2 times 4 gives us 8, 8 plus 3 gives us 11. Okay, so 2 times 4 plus 3 will give us 11, and this is our remainder, which will be 3 mod 4. And for the next one, we have it as 5 plus 12 equals 17. This is 4 times 4 gives us 16, plus 1, which gives us 17. So 1 is our remainder. This gives us 1 mod 4. Alright, and the next one we have as 9 plus 21 equals 30. This gives us 7 times 4, which is 28. 28 plus 2 gives us 30. And this is our remainder. 2 is our remainder. So this gives us 2 mod 4. Alright, now we have this as this. So we've looked at 3 ways of solving modular arithmetic. So looking at our next question, it says, find the following numbers in their simplest form. Now this is working with mode 3. Now if you are working with mode 3, we can either do 2 ways, okay? Either we use a number cycle or we go by our first method or second method, whichever way we feel comfortable. Now let's look at our number cycle. Alright, if we have a number cycle, 0, 1, 2. Now since we are working with mode 3, our digits will be 0, 1, and 2. Always remember that. Now the first one is 5 mod 3. In the simplest form, we count 1, 2, 3, 4, 5. That gives us 5 mod 3 would give us 2 mod 3. Why? If we have 5 divided by 3, okay, this will give us 1 remainder 2. So this remainder is what we are having written down here as 2 mod 3. Okay? Or if we go by the other method where we have it as 1 times 3 plus 2, okay, this is a remainder to give us 2 mod 3. Alright, now for the B part, we have 19 mod 3. 19 mod 3 would be, alright, let's count. From here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 mod 3 will give us 1 mod 3. Now using our other method, we have it as 19 divided by 3 will give us 6 times 3, 18. So this will be 6 remainder 1. So 1 remaining will be our mode. Expanding in this method, we have it as 6 times 3 plus 1. Since 6 times 3 is 18, plus 1 will give us 19. So this gives us 1 mod 3. Alright? Okay, next we have 60 mod 3. 60 mod 3. Now 60 mod 3 will give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. So that means 3 gives us 0. So this becomes 0 mod 3. Okay? Now, using our other method, we have it as 60 over 3, which will be 20 remainder 0. The next one, we have it as 20 times 3 plus 0, which is 0 mod 3. So our next question, D, minus 31 mod 3. Now, well, something special about this. This is not just a positive number. This is a negative, minus 31. Now, remember, when we worked with a positive, we went clockwise. So when working with negative, we go anti-clockwise. Okay? So using a number cycle, we have it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. That means a negative 31 would be 2 mod 3. Alright, now in using this formula, we will look for what number are we going to add up to give us 31. We have it as 11 times and 10 times 3 positively will give us 30 plus 1, 31. But since this is a negative, we are looking at a higher number. So we are looking at minus 11 times 3, which gives us minus 33. Alright? Minus 33 plus 2 will give us minus 31. Okay, minus 33 plus 2 gives us minus 31. So since this is a remainder, we have it as 2 mod 3. Alright guys, if you've enjoyed this lecture so far, don't forget to like, subscribe, and click on the notification buttons for more updates. Stay with us as we get right into more examples on modular arithmetic. Don't forget to share this link with your friends. Alright guys, our next question says, reduce 40 to its simplest form in mode 3 to mode 5 and mode 9. Okay, now to work on this, to reduce 40, 1a, we have mode 3. So this we are looking at 40 mode 3, which will give us 3 times 10 is 30, 11, 33, 12, 36, okay, 13, 39. So this becomes 13 times 3, that is 39, plus 1 to give us 40. 13 times 3, 39, plus 1 gives us 40. So this becomes 1 mod 3 for this. Now for B part, we have 40 mod 5, which will give us 5 times 8. 8 times 5 is 40, plus 0 still gives us 40. So this becomes 0 mod 5. Now for C part, we have it as 40 mod 9. Okay, 9 times 4 is 36. So this becomes 4 times 9, 36. 36 plus 4 gives us 40. So this would be 4 mod 5. Alright, now you can see one number in different modes have different answers. Okay, looking at question 2, our question 2 says minus 2. The operation here is addition. So we are looking at minus 2 plus minus 9. Minus 2 plus minus 9, which gives us minus 11. Alright, minus 11 in mode 4. Now, the easiest way to work with a negative is to find the positive value. Now, for mode 4 in the positive and 11 in mode 4, the positive will be 2 times 4, okay, which is 8 plus 3 to give us 11. But now, since you're working with a negative, we have to find a higher value. Since 2 times 4 will give us 8, we are doing 3 times 4, which will give us 12. So this will give us minus 3 times 4, which gives us minus 12. Now, what are we going to add to minus 12 to get minus 11? Will be plus 1. So 3 times 4 will be 12 minus 1 to give us 11. So this gives us 1 mod 4. So always remember that when you work with a negative, you increase the value of this positive to get your negative. Okay, or you can use your number cycle and count backwards to get your value. So if we look at our number cycle for mode 4, this is 0, 1, 2, and 3. Now, since it's negative, we count backwards. Okay, so this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is our 11, stopping at 1. That is why we have it as 1 mod 4. Okay, the next one is, our operation here is division. Now, the good thing about division is that you can have more than one solution or no solution. So for this, we are having question 3, we have it as 6 divided by 5. Okay, now we put this in an equation form to be 6 over 5 equals x. Alright, now we can write this to be 6 equals 5x, or 5x equals 6. Okay, let's put that 5x equals 6. 5x equals 6. Okay, now having it as 5x equals 6, we are going to look for, and this is mode. Oh, sorry, I skipped one question. Okay, we'll get back to that. This is mode 4. Now, since it's mode 4, we are going to add 4 to our right hand side. This becomes 5x equals 6 plus 4. Okay, since we are working in mode 4, remember that this is mode 4. Okay, since we are working in mode 4, 5 plus 6 equals x. So this gives us 5x equals 10. So therefore, x equals 10 over 5, which is 2 mode 4. So our 5x, our 6 divided by 5 will give us, in mode 4, will give us 2 mode 4. This is for question 4. Sorry. So for question 3, we have it as 13 plus 41. Okay. The operation there is 13 plus 41 mode 5. Since we have it as mode 5, 13 plus 41 would give us 44. So we are looking at 44 mode 5. Okay, so this will give us, 44 mode 5 will give us 8 times 5, which is 40, plus 4, which gives us 44. So this will be 4 mode 5 as our answer. And for the fifth question there, which our operation there is division, we have it as 3 divided by 7, okay, mode 5. Alright, same way we did the first one, we have it as in equation form 3 over 7 equals x. Okay, so this gives us 7x equals 3. Now, since we are working in mode 5, we add plus 5 to this. Okay, so now we are having 7x equals, if we add plus 5 to this gives us 8, right? 8. Now, can 7 divide 8? Yes, it will divide it, but we'll have a remainder of 1. Okay, but we are looking at, can we get a perfect number that 7 can divide in this? Now, from there, we can look at 5 times 7. Okay, now if we go, 5 times 5 is 25, plus 3, 28. That means 7 can divide 28 perfectly. Okay, so this becomes 3 plus 25. Okay, now in division, another thing to also note in division is that you are looking for a perfect number that can be divisible by your coefficient of x. Okay, so that's why we are going 5. Since if we do 3 plus 5 will give us 8, is not divisible perfectly by 7. We add another 5, which gives us 13, is not still divisible perfectly by 7. So 13 plus 5 gives us 18, still not still divisible by 7. We add another 5, plus 5 will give us 23. Okay, now it's not still divisible by 7. So if we do 23 plus 5 will give us 28. Now this is divisible by 7. So this gives us 28. Okay, so our 7x equals 28. So therefore, x equals 28 over 7, which gives us x equals 4 mode 5. Alright, that's for our division. Now, if you're working on multiplication, same way, okay, you have, let's look at, if we have 3 times 5 mode 2, okay, this will become 15 mod 2. Okay, so 15 mod 2 will give us 15 mod 2 will be 7 times 2 plus 1. Okay, 7 times 2 14 plus 1 15. So this gives us 1 mod 2. Okay, so let's be aware of how to use our numbers both for division, multiplication, addition, and subtraction. Alright guys, with this we've come to the end of today's tutorial. Thank you for watching up to this moment. Don't forget to like, subscribe, and share this link with your friends. See you in our next class. Thank you.